Here we go. On your note guide, right where you see power, exponent, base, go ahead and write 3 to the, watch this now, 3 to the 4th power. Do that for me. Nice and big. Take up all that space like this, like I did on your paper, please. Do that. You guys are Math 3 students already, so you've seen exponents. You've seen stuff to some power. There's no doubt about it. The problem is the vocabulary and the concepts are all mumbled, jumbled, and confused in your head. That's why you're in my class. We're going to fix the confusion. The base is the 3. I'm going to put an arrow from the word base to the 3. So anything that's being raised to power, that's your base. The exponent is a 4. So far, so good. Pretty straightforward. Then what's the power then? Where should I draw an arrow for the power? Well, that's the exponent though. No. 3 times, so 3 to the 4th means 3 plus times 3 times 3. Someone else said something else? The whole shebang! Put a box in over the 3 and the 4. The power is the exponent with the base. Nice. That's easy. Vocab is easy. We just gave an example and just pointed at stuff, just so you know what a power is. A power is a base with the exponent. Exponent is a little number. Whatever's being raised in a little number is a base. Nice. So far, so good. Rocking and rolling. Underneath that on your notes, we're going to go over 7 quick exponent rules, rules of exponents. Go ahead and shut your computer, Solodio. Right now I have the floor. So I'm going to go over 7 exponent rules that are right in front of your face on that note guide. You're going to number them with me. And I'm going to go over a quick example of each, and we're done. Then you go off and try some on your own with the assignments from last week, which was C13 and C14. Okay, here we go. Watch this. Watch this. So let's go ahead and all right, so on your note guide, right there where it says core concepts, you see the 0 exponent rule. So go ahead next to the 0 exponent rule, go to write number 1. And then next to negative exponents, write number 2. That's the second rule. Let's keep going. Flip the page. And that's number 3, 4, and 5, so on. Let's 3, 4, and 5 here. Let's see. Yeah, that'll be it. Nice. So flip that page. I'll put it on this so I can write on my screen here. So next on the other side, product of powers is going to be the 3rd rule, put 3. Quotient of powers, the 4th rule. Power of a power is a 5th rule. Do that next, do that with me please. And then the last 2 are the ones at the bottom from the other side, right? Let's see. Right here. The last 2 are power of product here. All right, so let's see. So we have 7 rules. Each rule is described in different ways. Each rule is either described in rules, in numbers, or with algebra. When I say algebra, I'm talking about variables, letters. But every rule is just described in three ways, with words, numbers, and algebra. But they all mean the same thing in a different way. Let me show you what I mean. Look at it in words. For any non-zero number, a to the 0 power is 1. Okay? For any non-zero number. If it's raised to the 0 power, it's going to be 1. In other words, look at an example with numbers. 4 to the 0 power is 1. All this is saying is, look, anything that's raised to 0 power, it's going to be 1. Except what number?
0.
Exactly. It's undefined. So think about how many numbers that are not 0. There's literally an infinite amount of numbers that are not 0. Every single one of those in your mind that's a not 0 number, if you raise it to the 0 power, it's going to be 1. That's all this rule is saying. Let me give you some examples. Put EX. Rios, what's your favorite number?
18.
I'm going to take Rios' number to the 0 power. It's 1. Cruz, what's your favorite number?
7.
I'm taking Cruz's number to the 0 power. 1. That's all this rule is saying. Don't overthink it. So cram in these examples wherever you see. Yeah, there's some stuff on the right. There's some space on the right there. Come on. Some of you want to start crying? This class is not hard. Any non-zero number to the 0 power is 1, except 0. It's undefined. In other words, you take 0 to the 0 power, it's undefined. In other words, things that don't exist don't have definitions. 0 to the 0 power doesn't exist. It's like a unicorn. Don't exist. Very philosophical claim there. Negative exponents. Second rule. Again, they describe it in words, numbers, and algebra. The negative exponent rule, we just actually covered it in warm-up. Miss Chavez gave it a shot. Remember the x to the negative 7th power? So look at this, is just saying, look, just make it into a fraction, reciprocate it, and turn the exponent to positive, and you're done. Here's what numbers. Here's what some variables in algebra. Let me give you an example. X to the negative 8th power. Make the expression into a fraction first by putting a 1 underneath it. And all you do is reciprocal. Take the reciprocal. To reciprocate means to flip the numerator and denominator. I'm going to put the denominator in the numerator, and the numerator in the denominator. But when I reciprocate, the exponent becomes positive. That's all this rule is saying. That's not hard, you guys. You got a negative exponent, take the reciprocal, change that exponent to positive, and you're rocking and rolling. You're done. Wow. Beltran, what's your favorite number?
3.
I'm going to take Beltran's favorite number to the negative 3 power. Again, you have some space to the right. That's where I'm putting these examples. You with me, Solorio?
Yeah.
Watch this. Over 1, I'm going to reciprocate that puppy, but change it to positive. Done. Now, to be sure, we could do 3 to the 3rd power, 3 times 3 times 3. But for now, with the work that I'm assigning you, just leave it as a power right now. Don't worry about taking 3 to the 3rd power, 3 times 3 times 3. Don't worry about that. You could if you want, but you could just leave your answer like this, as a power. Notice I said a power. Remember, a power is a base with the exponent? It's a base with the exponent. Base, exponent. I said leave it as a power. You could leave it that way for now. Or, if it really bugs you to leave it as a power, you could just do this. Right? 3 to the 3rd power means 3 times 3 times 3. So what I'm saying is you can leave your answer like this. You don't have to go all the way to this. But if you want to go all the way, and reduce that power, knock yourself out. I don't really care about that right now. What I care about is you applying these rules of exponents. Questions on rule number 2, moving right along. Product of powers. Cruz saved the day earlier on the warm-up. Look what this is saying. We did the product of powers on the warm-up problem. Look at it, it's right here. Same base, x and x were the same base, we're multiplying. Cruz told me to add the exponents, and that's exactly what I did. Look at it. That's all this, that's a rule right here. That's number 3, the rule number 3. Look at the words. To multiply powers with the same base. What's the base, you ask? Well, we just took notes on the base, right? The base is whatever is being raised to the power, right? So this is saying, look, if you have the same base and you're multiplying, just add the exponents. Look, to multiply powers with the same base, add their exponents. Look at it, they gave you an example in numbers. 4 to the 6th times 4 to the 3rd. Look at same base is 4. So you just add it. So it's 4 to the 6 plus 3 power, which is 4 to the 9th power. Algebra, a to the m times a to the n power is going to be a to the m plus n. So Soloto, you want me to take your R stamp away, that's cool. You're not supposed to be watching stuff when you're taking notes, but it's up to you. Have it your way. Check this out, let's do some examples. X to the 5th times x to the 2nd. I'm just making it up off the top of my head. Same base, x and x. So all we do is do what it says. Add the exponents. X to the 7th. It's ridiculously easy. That's too easy. I'm just done with one example. I'm done. Let's go on number 4. I don't want to insult your intelligence. It's so easy. Number 4 is like number 3, except we're dealing with the quotient of powers. Instead of product means multiplication, now we're dividing. Quotient is a fancy schmancy word for dividing. Look at, we're dividing with the same base. 4 to the 6th divided by 4 to the 3rd. What do you do with the exponents? You subtract those puppies. So to divide powers of the same base, subtract their exponents. Let me give you an example. X to the 5th divided by x to the 2nd. I have the same base. What is the base there? For both x to the 5th and x to the 2nd. What's the same base? What's the base there for each one? X. Same base of x, okay. And I'm dividing, so this says subtract the exponents. So this is going to be x to the 5 minus 2 power. Nice. So that's going to be x to the 3rd power. Rocking and rolling. Last 3 rules and we're done. Questions so far? Here we go. Power of a power. What the heck does that mean? Well, define a power of a power. In other words, something to a power, then raised to a higher power. Look at the example. 4 to the 6th power raised to the 3rd power. Power to a power. You're taking a power to a higher power. What? That's easy. Just multiply the exponents? You gotta be kidding me. Look at the example of numbers. 4 to the 6th to the 3rd power is just 4 to the 6 times 3. 4 to the 18th power. Done. Come on. Valladares, what's your favorite number? I'm going to take Valladares' favorite number, raise it to the 2nd, but then raise that puppy to the 5th. A power to a higher power. Thank you. 7 to the 10th power. This coffee's good, by the way. Last two examples, last two rules rather, and we're done. Moving right along. Questions, questions? You guys are too quiet, it gets me worried. Way too quiet. Maybe you're just in shock now that you're learning. The past week with my COVID, you guys are just like lagging, doing nothing. No offense, but that's really what's going on, right? I shocked you into learning today. I don't know. That's my guess. Power of product property, rule 6 says, to find the power of product, that means if stuff is being multiplied in parentheses, look at, you have parentheses right here, 3 times 2. Stuff is being multiplied, that's why the word product. The power, look at the 5th power, the power of product. So 3 times 2 is being multiplied, right? 3 times 2 is being multiplied in parentheses and then raising it to the 5th power. What this rule says, look, you could take every factor in the parentheses and raise it to the 5th. Look at, they took 3 to the 5th power times 2 to the 5th power. They took every factor inside and raised it to the 5th power. That's all it's the same. This only works for multiplication. That's why it says product. Product is a fancy word for multiplication. This only works for stuff that's being multiplied in parentheses, right, Solorio? Check it out. Let's say x times y times z. Look at that's being multiplied in parentheses. All to the 7th power. How about that? Give it to me. Someone apply this rule. What would it be? X times y times z in parentheses to the 7th power. So I'm multiplying a bunch of garbage in parentheses, and I'm taking it all to the 7th power. Help. Someone apply the rule. Go. To the
7th power.
rocking it. Y to the
7th power.
thank you. Z to the 7th. Done. That's all this rule is saying. You have a bunch of garbage being multiplied in parentheses, and it's all being raised to power. You can take every one of those factors to that power. Pretty logical. It's not a big deal. It's not rocket science, right? Just kidding me?
Yep.
This is not rocket science at all. But let me give you a little bit of rocket science. This does not work. Put a big fat no with like 3 exclamation points, actually more. What are those x plus y plus z to the 7th power? The temptation for all students is to say, oh, no problem. I learned this in Mungia's class. Just take everything to the 7th. No, 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 no. No. This only works for multiplication, ladies and gentlemen, when stuff is being multiplied, not when stuff is being added. So put a big fat no. No. But yes right here, because this is all multiplication inside. They're very similar. 6 and 7 are very similar. Look at the names are even similar. Power of a product, that means multiplication, versus power of a quotient. That's a fancy word for division, right? Power of a quotient. So stuff just being multiplied in parentheses, or divided rather in parentheses and taken to the 5th power. You can take everything that's being divided to the power. I don't know what else to tell you. Simple. It's right there. Let me give you an example. Guzman, what's your favorite number?
13.
I'm going to divide Guzman's number, favorite number, by Solodio's favorite number. What's your favorite number, Solodio?
11.
And I'm gonna take all that garbage to the negative 8th power. What? Who's winning?
What?
You heard me. Euro League? Who's better, Ronaldo or Messi? What? I'm gonna take Guzman's number divided by Solodio's number, all to the negative 8th power. Watch this. That becomes, just take everything in parentheses to the negative 8. Come on. It's all the same. It's all simple. (13 to the negative 8 divided by 11 to the negative 8. I could go on technically, but I'm going to leave it like that for now, just so you can see the rule applied. That's all I care about right now.